Hey students, let's solve one previous question of DBMS. This question was asked in GATE CS 2026 set 2, question number 32. In the context of schema normalization in relation DBMS, consider a set F of functional dependency. The set of all functional dependency implied by F is called the closure of F. To compute the closure of F, Armstrong's axiom can be applied where X, Y, Z are set of attributes over relational schema. The three rules of Armstrong axiom are described as follow. Reflexive: if Y is subset of X, then X implies Y. Augmentation: if X implies Y, then XZ implies YZ. We are adding Z to both left and right for any Z. Next, transitive: if X implies Y, Y implies Z, then X implies Z. The additional rule of union is defined as follow. If X implies Y, X implies Z, then X implies YZ. We are combining this right side. It can be proved that the additional rule union is also implied by the three rules of Armstrong's axiom. Listed below are four combinations of these three rules. Which one of these combinations is both necessary and sufficient for the proof? And four options are given. Here minimum is option C, that is transitive. X implies Y, Y implies Z, means X implies Z. So can we obtain union from transitive like X implies Y, X implies Z and X implies Y and Z? No, we cannot obtain union from transitive, hence option C is false. Let's check option D, augmentation and transitivity. Can we obtain union from augmentation and transitivity? Now union X implies Y is given, X implies Z is given. Can we prove that X implies YZ by using augmentation and transitivity? So X implies Y, then X implies XY. That simply you can write as X implies XY. Here we use the augmentation. Now X implies Z, XY implies ZY. We can rearrange this. So XY implies YZ. Here we use the augmentation. We add Y in both sides. Now from these two, X implies XY, XY implies YZ. We can obtain X implies YZ by using transitive. Hence, we can obtain union rule by using augmentation and transitive. That's why option D will be true. In case of union, X implies Y is given, X implies Z is given, then X should be implies YZ. So X implies Y is given, we can add X in both sides by using augmentation. So that will be X implies XY. And X implies Z is given, we can add Y in both sides by using augmentation. XY implies YZ, X implies XY, XY implies YZ, hence X implies YZ by using transitive. Hence, it proved that by using augmentation and transitive, we can get the union. So, only transitive is false, augmentation and transitive is true. Now, option A, that is reflexive, augmentation and transitive. Just augmentation and transitive is enough for union. Here it's given which one of these combination is both necessary and sufficient. So these two, augmentation and transitive, is necessary and sufficient. We don't need reflexive. That's why option A is false. Now option B, reflexive and augmentation. There is no way we can use reflexive and augmentation and we can get the union rule. As here X implies Y is given, that means X equals to Y, and X implies Z is given, that means X equals to Z. So using this, we can say X equals to Y equals to Z, but we cannot combine X implies YZ both. Hence reflexive and augmentation, by using both we cannot get the union. Answer will be option D. By using augmentation and transitive, we can get the union. That's why these three rules are in Armstrong's axiom. These are the basic rules. By using these, we can get other rules. So union is one of them. there are some more rules like decomposition that we can also get by using these three rules. I already discussed functional dependency during lecture. Just go through the lecture, and if this lecture is helpful for you, please like, share and subscribe. Thank you. Bye bye.